Hello guys, welcome back to my YouTube channel on Sagacious Learner. So in this video we're going to be talking about work, energy and power. So work, energy and power. So let's talk about work. So what is work? Work is done when a force acts on an object and causes it to move in a direction of the force. Work is done when an object moves in direction of the force. Let's consider this object. So this object is being displaced by a force F. So this object will move in this direction, and if this object move in this direction with a distance, it can be any distance ranging from 1 to infinity. So work is done on this object. So work is now equals to F dot S, where F is the force and S is the distance, or force can also be represented as this, where the force is acting at an angle to the object. Look at what I mean here. So let's consider this object and force is acting on this object. Instead of this force to act in horizontal, this force is going to act at an angle to this object. For instance, look at this angle. This force is acting at an angle to this object. So we are going to convert, in solving questions like this, we are going to convert this force into either vertical or horizontal components. So to do this, we have force is equals to, we can say F cos theta, or we can say F sin theta. This is for converting it to horizontal, and this is for solving into the vertical component. So since we have understood this part, so let's go over to the key points. The first key point is work is a scalar, not a vector, which means that work has magnitude but no direction. A vector's quantity are those quantities that have magnitude and direction. If the displacement is 0 or the force is perpendicular to the displacement, no work is done. Negative work occurs if the force opposes the motion. Example, we have the gravitational force and we have the frictional force. So frictional force always oppose any object in motion. Like when you're talking about frictional force, you're talking about force that exists between two objects that comes in constant. So this force tends to oppose one of the force that is in motion. So frictional force, this is a natural phenomenon that stops a moving object or tends to slow down an object in motion. So gravity, when an object, consider an object thrown vertically upwards into the space, this force will be decreasing by 10 meters per square second in every second due to is acting in opposite direction as the force of gravity is acting. Let's consider this object or this block. So if this block is thrown vertically upwards, gravity is acting perpendicularly downwards. So this force will now be decreasing. The speed rate of this object will be decreasing. Now, to solve this kind of force, we are going to convert this using, are we going to use this first one or are we going to use the second one? Since it's vertical, we are going to use F sin theta if we want to resolve this kind of force, so that we can use it to find the work done. So the kinetic energy of this object will be decreasing in every second since this object is acting in opposite direction to the gravitational force. So let's talk about energy. So once we talk about energy, once comes into your mind, so energy is the capacity to do work or the ability of an object to do work. So there are many forms of energy, but most commonly discussed are kinetic energy and potential energy. So this kinetic and potential energy are classified or can be found in the mechanical energy. So we can also write the mechanical energy as kinetic energy plus potential energy. This is also expression of kinetic energy. So this kinetic energy we are talking about is given as half mv squared. So this is the formula you will use to find the kinetic energy of any object, the energy of the object. So if you talk about kinetic energy, we are talking about energy in motion. Why if you talk about potential energy, you're talking about energy at rest, or when an object or a body is in motion, we are talking about kinetic energy. But when an object is in rest or at rest, we are talking about potential energy. So this potential energy can be expressed as mgh. This is the potential energy. We Potential energy is equals to kinetic energy, but we are coming to that. So in kinetic energy, as you can see here, this is the formula. So this half is a constant, while this m here is the mass and v is the velocity in meters per second. While in potential energy, m is the mass, g is the acceleration due to gravity, which is a constant, and h is the height, which varies. Increase in the height of an object, the more potential energy an object possesses. Decrease in the height causes decrease in potential energy. So we say that kinetic energy is equals to potential energy. So how is kinetic energy equals to potential energy? So we're going to use a relationship to find or formulate the formula where v is equals to, or we're going to find v using kinetic energy is equals to potential energy. So we say that our kinetic energy is half mv squared and our potential energy is mgh. So kinetic energy is equals to potential energy. Reason: in conservation law of energy, energy can neither be created nor destroyed, but can be transformed from one form to another. So kinetic energy cannot be created but can be transformed from one form to another. So that's why you say kinetic energy is equals to potential energy. So let's make v the source of formula in case in a question if you are asked to calculate the velocity, if the velocity of an object or the speed of an object, if they give us the parameters for potential energy and kinetic energy. So we can now go ahead and make v the source of formula. So we have that v squared is now equals to mgh. So if I should multiply here by 2 over 1, multiplying here by 2 over 1, this we cancel. So here I will now have 2 because 2 over 1 is 2. So here now I will now have v squared is equals to mgh, 2 mgh, then v squared is equals to 2 mgh, then v is now equals to square root of 2 mgh. So this is the formula for kinetic energy. This is the formula for finding the speed of an object if we are given the parameters of potential and kinetic energy. So let's talk about power. So once we talk about power, what comes into your mind? So this power in discussion is the rate by which work is done or energy is transferred. So if you're talking about power, we are talking about the rate by which work is done. Power, The shorter the time, the higher the power or the faster an object can be, while the higher the time, the decrease in power or slower an object can be. So power can be expressed as W over T, where this W is equals to force times distance all over T. So since power is equals to force distance all over T, recall that distance displacement over time, we can call this distance over time, we can also call it displacement over time since they are in one direction. So recall that displacement over time is equals to velocity. So in case if you're solving a question and they give you force and velocity, what you are going to use to find the power is force times velocity. Reason because since s over t is equals to velocity, we can now go ahead and write f dot v, implicating that power is equals to f dot v. So if you are solving a question where you have force and velocity, go ahead and use force times velocity to find your power, because you will be seeing this question as we are practicing some problems facing this. So let's summarize power, work, and energy. Then we can now dive into calculation. So in our summary box, recall that work is done when a force moves an object in the direction and a distance. We can say work is done, and energy is the capacity to do work and comes in form like kinetic and potential energy, while power is the rate at which work is done or energy is transferred. So this is all we need. So let's dive into the calculation part. So let's practice some question. The first question is work done. A 10 Newton force is applied to move an object 5 meters along a flat surface. How much work is done? So recall that work done is equals to force times distance, and force times distance, since our force was 10 Newton and we have distance to be 5 Newton, so our work done will now be equals to 10 times 5, which is equals to 50 joules. Work is represented in joules. So let's solve the number 2 question. We have that kinetic energy. So this is question relating to kinetic energy. So a 2 kilogram object is moving with a speed of 3 meters per second. What is the kinetic energy? So this is objects moving with 3 meters per second. They are asking us the kinetic energy, where we have that our mass is 2 kilogram and our velocity is 3 meters per second. So the formula for kinetic energy, as we have said before, is equals to half mv squared. So since we have that our kinetic energy is half mv squared, where we have mass to be 2 kilogram and velocity to be 3 meters per second, so we can now go ahead and use this formula. So half times 2 times 3 squared, 3 squared is 9, so this will simply become 9 joules. So this will simply become 9 joules. Let's solve for potential energy. A 5 kilogram book is placed on a shelf 2 meters above the ground. What is the potential in it? So recall that potential energy is equals to mgh, where we have that our mass is 5 kilogram, our distance is 2 meters, but gravity is a constant, it does not change. So you can use gravity as 9.8 or 10 meters per second, but using 9.8 is preferred. So let's implement this in our equation. We have that our mass is 5, so here will now be 5 times our gravity is 9.8, and our height here was 2 meters times 2. So our answer will now become 98 joules. So let's practice question on power. If a person does 200 joules of work in 10 seconds, what is the power they exert? Recall that power is equals to the rate by which work is done. So the rate by which work is done is work done over time, and work done is in the question. Since we have our work to be 200 joules and our time to be 10 seconds, so we can go ahead and implement this in the equation. So we have that our work is 200 joules, so here will become 200 joules over 10. So 0 cancel 0, and we have here is 20 watts. Power is measured in watts. Let's practice more questions. So a 15 Newton force is applied to pull a sled 10 meters across a snowy field. If the force applied horizontally, how much work is done? So recall that work done is equals to force times distance. So we have our force to be 15 times our meters, which is 10. So here will now be 150 joules. Second question, which is a car of mass 1000 kilogram is moving at a speed of 20 meters per second. What is the kinetic energy? Half mv squared is the formula for the kinetic energy. So since we have that our kinetic energy is equals to half mv squared, so 1000 is our mass times our velocity is 20. Since we have squared in our equation, so we are going to square this 20 times half, can be 0.5, as half we can also represent it as 1 over 2. So I'll now write 1 over 2. So this is now equals to 200,000 joules. Number 3, potential energy. So 3 kilogram rock is held at a height of 10 meters above the ground. What is the potential energy? Recall that potential energy is equals to mgh. So 3 is our mass according to the question, and 10 is the height, but we have our gravity to be 10, so we write 10, and our height is 10. So here will now become 3. So this is now 300 joules. So fourth question, a motor does 1500 joules of work in 5 seconds. What is the power? Recall, power is work done with time, the rate by which work is done. So our power is now equals to W over T. So since we have 1500 joules over our time is 5, so this is now equals to 300 watts. So now number 5 question, we have a 2 kilogram object is lifted 3 meters vertically after it is released. After it is released, it falls freely. Calculate, first question, the potential energy when it was at the height of 3 meters. So the potential energy is now equals to mgh. So our mass was 2 kilogram, our height was 3 meters, and our constant acceleration due to gravity is 9.8. So this is 2 times 3 times 9.8, which is equals to 2 times 3 times 9.8 is now equals to 58.8 joules. So the second question is kinetic energy. So let's calculate for the kinetic energy. Listen to this question carefully. They say 2 kg object is lifted 3 meters vertically. After it is released, it falls freely. Calculate. We have done the first one, which is the potential energy. The second one is the kinetic energy just before it hits the ground. The kinetic energy just before it hits the ground. So to solve this kind of question, first let's write our formula. Kinetic energy is equals to half mv squared. So to solve this question, we have to find v, which is our velocity. So to find v, we have to use equation of a straight line. So which equation of a straight line should we use? We have 3 to 4 types of equation of a straight line. So but we're going to use this one. V squared is equals to u squared plus 2gs. This should be able to is g because it's under the influence of gravity. Is an object is projected into the space. So since we're looking for this velocity, we're going to make it this as a formula. And from this question, they said after it is released, just watch from here, and it falls freely. So its initial height or its initial velocity is 0. So we are going to cancel it out because it is at potential energy there. So there it is 0. So we are going to remove it. Gravity is always negative, but why is this plus 2gs instead of minus 2gs? This is plus 2gs because this object acts in direction of the force of gravity, because it was released from the height. It was not projected vertically upwards. It was in a height and it was released. So it will go according to the influence of the force of gravity. So our v squared will now be plus 2 times 10 times 3, which is 2 times 10 times 3. 10 times 3 is 30, and 30 times 2 is 60. So v is now equals to square root of 60. So square root of 60 is now equals to 7.745 meters per second. So approximating this, we now have 7.75 meters per second. Now, how are we going to solve for our kinetic energy? Since we have everything we need for this kinetic energy, we now have all the parameters. So what we're going to now do is to implement it. So recall that kinetic energy is equals to half mv squared. So half is 0.5 times our mass, which was 2, times our velocity, which was 7.75 squared, because in our equation we have squared. So kinetic energy will now be equals to 0.5 times 2 times 7.75 squared. So our kinetic energy is 60.1 joules, or you can simply leave it as 60 joules. So this is our kinetic energy. So let's solve more questions. This is advanced questions. So a block of mass 10 kg is moved along a horizontal frictional surface by a constant force of 50 Newton. If the block starts from rest and move 20 meters in the direction of the force, calculate the work done by the force. So to calculate the work done by the force is work done. Recall that work done is force times distance. So our work done will now be 50 times 20 because our force is 20. So here will now be 50 times 20 since 20 is our distance, which is the meters. This will now give us 1000 joules. So the big question is the final speed of the block after 20 meters. The final speed after 20 meters becomes, recall that work done is equals to kinetic energy. And this work done, they said after 20 meters, and we have 50 Newton as our work, and we already have our work done to be 1000 joules. So here will now become 1000, which is equals to kinetic energy is half mv squared. So we now have half v squared is now equals to 1000 divided by 10. This 10 is from our mass in the equation, which is 10 kg. So 10 cancel 1000, we have v squared is equals to 100. So to remove this half, I will multiply here by 2. So multiplying here by 2, we now have 2 times 2 will now give us 1, and 2 times this will now give us 2 times 100, which will now give us 200. So square root of 200 will now give us 114.14 meters per second. So this is the speed of the block after 20 meters. So this question is question of kinetic energy and power. So the question says 1500 kg car accelerates from rest to speed of 25 meters per second in 20 seconds. Calculate the kinetic energy. So recall that kinetic energy is equals to half mv squared, and half mv squared is 0.5 times our mass in the equation was 1500. So this is 1500 times what's our v squared, and our v squared is our speed, which is 25 squared, and 25 squared is 625. So 0.5 times 1500 times 625 will now give us 468,750 joules since its energy. So the big question, the average power required to achieve the speed. So the average power, record that power is equals to this over time, work done with respect to time. So what is our work done? Work done is equals to kinetic energy. So our work done is equals to our kinetic energy. So our kinetic energy was 46750 joules divided by our time here was 20 seconds. So divided by 20 seconds. So power will now become 2337.5 watts. So this is our power. A 5 kg object is thrown vertically upward with an initial velocity of 20 meters. Ignore air resistance. Calculate the maximum height of the object. So at maximum height, the final velocity is equals to 0. So we're going to use this equation. V squared is equals to u squared minus 2 gs. So at maximum height, final velocity is equals to 0. So here becomes 0 squared, which is equals to our initial velocity was 20 squared. So here will now become 20 squared minus 2 times 10 and x. So here will now be 20s, which is equals to 400. Since we have 420, we are going to make s the series of formula. So making s the series of formula so we can find the maximum height. So x will now become 400 over 20. So 0 we cancel 0 and 40 we divide by 2. So s will now become 20 meters. Or your s can be equals to 20.4 meters if you use your gravity as 9.8 or 10. If you use 10, your height should be 20 meters. Why if you use 9.8, your height should be 20.4 meters. So B is to calculate the potential energy at maximum height. So the potential energy at maximum height, recall that our potential energy is P dot A equals to mgh. So we have our mass to be 5. So this will now become 5 times, and we have our gravity to be 9.8 times height, and we have our height to be 20.4. So this will generally become 1000 joules. So your answer should be 999.6. So if you approximate it, you now have 1000 joules. So to calculate the time it takes to reach the maximum height, we are going to use this formula. V is equals to U plus AT. But since it's under gravity, so we're now going to now write V is equals to U minus GT. At maximum height, velocity is 0. So here will be 0. And our initial velocity was 20 meters per second minus GT. So our GT is 9.8. So 9.8 T is equals to 20. Then making T the source of formula, we're now going to write 20 divided by 9.8. We now have 2.04 seconds. So this is all I have for you for this video. Don't forget to like, subscribe, and hit the notification bell for more videos like this on Sagacious Learners.